All right, we're gonna get started on this. Now we just finished our unit test last lesson. I'm gonna work hard on trying to get it marked and get it back to you. We're gonna start on this new unit, and I call it, that's a biochem unit part. Now part of the thing about why we're teaching biochem, or why we're studying chemistry in biology, is because we are actually studying when we're studying biology, we're studying in a smaller and smaller scale. Right now, we're looking at things in the molecular level. In terms of understanding how things work in the cell level, how things work in a molecular level, we do need to have some understanding of molecular biology. So in this case, this lesson, as I said, it will be, as I said on Wednesday, this first lesson is a survey of all the different kinds of molecules that we'll study in this course. For each of those, we'll go into more detail. One of the things it's important for you to do is be comfortable. Be comfortable with dealing with the molecular structure. I'm going to be a little bit more hands-on and direct, do a little bit more direct instruction every class, just because it's one of those things where it's easier to learn if I teach it first, and then you're going to build molecules and memorize things. Okay? So, on the handout that I just gave right now, there's quite a bit of detail. For those of you who are in the chemistry class, this is a little bit, not so much of a review. I know I talked about it in my group, but also just keep in mind that so I talked about it in my group. So a few things. We're going to be talking about mainly carbon. Things are carbon, hydrogen, and oxygen, and nitrogen. So in this case, it's important for you to know how many bonds. We're talking about in organic chem mostly. We're talking about covalent bonds. Covalent bonds. So the electrons are shared between the two atoms. So in this case, carbon usually form 4 bonds, hydrogen only form 1, oxygen can form 2. Nitrogen can form usually 4 in a non-charged form. Did I say 4? Yeah. I wrote 3, I meant 3, somehow I said 4. Weird. Form 3 bond in a non-charged form if they ever form a 4 bonds, like NH4, they usually will be charged. So that's probably why I said 4 when I wrote 3. Okay? You can see single, and double, and triple bonds. So if you're in the chemistry group, you have a little bit of an advantage. Now, we're going to jump right into it. We're going to be looking at these 4 different groups of molecules: carbohydrates, lipids, proteins, and nucleic acids. Now, carbohydrates, usually, as it says here, that's information: carbon, hydrogen, and oxygen. The one that you will be studying generally will be in the ring form. So this is if you were on Wednesday when you're building the molecules, you had a glucose, you have a ribose. How are they similar? They're both rings. Okay? You're going to study in the IB in the ring forms. So glucose that you're going to study is a 6-member ring. So you start off 1, 2, 3, 4, 5, 6. Now the 6th one here is an oxygen, but if you're talking about the 6 carbon-wise, it will be 6 here. Okay? Now, on this bottom part, right down here, this is actually a picture of a beta glucose. This is a picture of a beta glucose. The reason why it's a beta glucose is because this OH group here points up. Okay? And the orientation of these H H and OH groups are important because if they are different, they will become what in chemistry you learn structural isomers. Okay? So in this case, we're talking about molecules that have same molecular formula, C6H12O6, but structurally different. Okay?
Can you repeat that? I just
So-
want to write it down.
Oh, sure. So structural isomers.
Alright.
Basically, same molecular formula, C6H12O6. You know I'm recording the same. Thing is, would be picked up. Different structure.
So
Okay.
the OH has to be above the H.
So the OH here is above the H for the first carbon. Yes,
Is it usual to do fructose in a 5 ring or a 6 ring?
6 ring.
Okay.
You say glucose or fructose? Which?
Fructose.
Fructose is a 6 ring, sure.
Okay.
Now, if you study organic chemistry in a higher level, not higher level as in like in university, you would study that.
Wow. That's really
You study that these ring sugar have open chain form. We're not going to go into that. It's higher. Okay. Now this is bait. What's going on?
We turn on and off.
It's a conspiracy, so we hold straight. Anyways,
This one I was trying. Are you going? No. Maybe are you going? Are you going?
Yeah.
It depends.
this is
We're
working.
not Sean going, right?
No, it's just when feels throat.
So you're gonna go?
Do you?
Yeah, I'm right.
Working?
I think I'm staying. I only have 2 periods like that.
I feel
Yes?
I applied for the University of Chicago presentation and I just I passed that.
Okay. I'm trying to find my adapter so I can just plug it in. I'm sorry for this weird version.
Oh my god, that is so awesome.
You just not going to school? You just stay home?
No, I just studied until like 4 a.m.
Oh my god.
Okay, I'm
You
not
had the exam? What was the exam?
adapter from the other copy right now.
She charges. She did. I charge this.
I can't do that. I need sleep.
Amelia.
Yeah.
I've been wanting to get it. I've been wanting to get it the past 3 days. I went on campus grade 7. I've been in
So
school.
weird.
Anyone have to put on the adapter?
An adapter?
Yeah.
We complained to me today I got
You
back.
could send one of us to
Ruby
IT
complained
to
to
get
me.
it.
She was like, never miss link.
Because I think IT has extra.
Sure, please.
Oh
Can
my
someone go get an adapter?
Oh, there you go. Everyone in
What's
my
going on?
best friends.
Huh?
Are you using AirPlay?
Yeah.
Just because like
Maybe just
server.
Maybe it's your laptop.
I don't know.
Oh, okay, done.
Seriously?
Yeah.
Oh my god, I talked to her. She like
Have you
took
tried
over the
disconnecting
fire.
and connecting
What
again?
if the kids do anything? And over their entire thing was so funny. He started explaining to me. He was like,
Where?
this is terrible.
Wait, what part of the school is this?
I literally took
In
her.
front.
Because the kids were like,
That does not work.
I didn't
Bro,
want to
it's
take
the front.
Here?
Does not work.
they're so
Have you never
funny.
seen the front of the school?
He was genuinely embarrassed. Like,
It's the
you know,
front.
like,
Search up the
Anthony
school, right?
Yeah.
like
Yeah,
her
but
and
you
all
said
their
that
friends
on
and everything.
Google.
Caitlin.
All right, so hi. While this is going on, I'm just going to draw it on the board. Now, drawing the glucose ring. By the way, the reason why it looks like this is to show you that this half of the molecule is sticking out of the page. This half of the molecule is behind the page. And you have a carbon, you have CH3OH here. Okay, for the alpha glucose, you do kind of need to remember the structure of the orientation of the OH. It's relatively easy. Down, down, up, down, 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 up, down, and then the rest are just hydrogen. That's all glucose.
Should we draw that?
Yes, please. Because in a moment, you're going to see the beta glucose, and you'll notice the difference. 6,5 go to 6. Wow. Seriously. So, what's the difference between alpha and beta glucose? Yes?
Alpha glucose on the first C, the OH is down.
That's it. That's the main difference. Or that's the only difference. Now, the rest of it is still the same orientation for the OH groups, but just because of the hydroxyl group or the OH group of the first carbon, this one points down, that's alpha glucose. Now, a little bit preview into next lesson or so, just because of this one OH group is pointing down, it affects whether when they form chains together, they're forming starch, which we can use as food source, or cellulose, which we cannot digest. Okay? It's just this one OH group orientation difference. Okay? So you do need to memorize that. That's just part of the deal. Questions so far about carbohydrates?
What's alpha and beta?
That's alpha glucose.
Like, what's alpha?
Alpha is the one that the OH is pointing at. Beta is the one that the OH is pointing at. Now, lipids. As you can see in the diagram, now lipids have two different parts that creates lipids. Okay, this whole molecule is a lipid molecule. However, if you look at, there's two parts that are separate. This part here, and this part here. Structurally, this part here. Now, this part here is what we call fatty acids. Okay? Fatty acids, for those of you who are in chemistry, what do these mean?
They're carbons.
They're carbons.
Each N and then it's a carbon.
Yeah, the N have carbon and each of these have carbon. So if I draw this, I'm going to do a shortened form because this is really long. A fatty acid molecule will look something like this. Carbon, OH, carbon, 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 carbon. It just continues on like that until, let's just imagine instead of so many carbons, it's a little bit shorter. So just 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Just imagine that this is only this small, okay? I don't want to draw out the whole thing. So in this case, you have hydrogen, 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 H, H. And then here, this carbon can form 4 bonds, H3 like this. All right? That is a fatty acid. Yes?
Sorry, I just remember your drawing, the 3 oxygens that are like in the row there on the left. Are they like a part of the second group or the fatty acid?
This here,
No,
this
yeah,
here,
yeah.
I'll get to it.
Okay.
Okay? I'll get to it. This here, by itself, is a fatty acid. Usually, just for you who only take bio and don't take chem, this, because no one really likes to draw things, especially complicated things, that's too long. So one of the way we draw this molecule out is a simplified form, which is like this. So instead of drawing all the carbons and drawing out all the hydrogens, the same molecule, I'll draw the same thing, would be like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, like this. Okay? So this is a simplified form of this. Okay?
So that form just says that the hydrogens are bonded with the
Yes.
carbons.
So since in organic chemistry, pretty much everything is carbon, hydrogen, oxygen, nitrogen, and whatnot. And so in this case,
They
all
need
these-
full valence shell, yeah.
all of these are carbons. If it's connected to a nitrogen or oxygen, they will draw those things out. But we kind of know, it's like, oh yeah, if it's not connected to other carbons or other things, it will be filled up with hydrogen. So they don't even bother drawing hydrogen. Okay, that's a simplified of the same molecule. Okay. Now, earlier you were asking, these oxygen is a part of the fatty acid, a part of the second thing. Now, the second thing here, as you can see, blah, 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 triglycerides. So in this case, this group here is actually glycerol. So here, I might as well draw a note like this. Okay. So this is a glycerol. On its own, this is a glycerol. And so in this case, there's oxygen here. There's 3 oxygen on the glycerol. Glycerol. Okay? So for a lipid, you have 1 glycerol and 3 fatty acids and combined together. Okay? We're not going to talk about the combination yet, but just the ratio of glycerol and fatty acid, you know, is 1 to 3. Glycerol, fatty acid, Fa. Okay. All good so far? Now, one fun thing about fatty acids, and for those of you who are in chem, if you have a double bond, what is your hydrocarbon has a double bond? You call it alkenes, E-N-E, okay? A-L-K-E-N-E. So in this case, you notice here, there are double bonds. So some fatty acids have double bonds. These have only single bonds. So because these are only single bonds, we call them saturated fatty acids. I'm just saying F.A. Did you learn this last year, Jordan?
No, wait,
Because these only have single bonds. Only single bonds. Okay? They're all single bonds here. Now, yes?
That depends on the carbon, right? Whether it's double bond or single bond.
Yep. Between the carbon-carbon bond, are they only single bond or double bond? Yep. Okay, so in this case, these two here on the bottom of the, oh yeah, use brown. These two here are what we call, because they have double bonds here, so you call these unsaturated fatty acids. Okay? Due to carbon-carbon double bonds. Okay? Just having a double bond makes it a unsaturated fatty acid. Now, going back to real life, how does that affect you? Well, when you talk about saturated fats, unsaturated fats, that's what we're talking about. Saturated fats, there's all single bonds here. Unsaturated fats, you have these double bonds in the fatty acid. Yes?
But just the whole thing makes the limits with the.
This whole entire thing makes limits. Yes?
And what about the trans fat?
Ah, trans and cis. Most people don't talk about this. Actually, people do talk about cis fat, right?
No, I've never heard that in my life.
Not as, you don't hear as much. Trans fat usually get the bad press. So, saturated fatty acid, unsaturated fatty acid. Under unsaturated fatty acids, you have two groups. You have the cis, you have the trans. They're both what in chemistry you will learn called stereoisomers. Okay, stereoisomers. And so what it means is this. Between the carbon-carbon double bonds, now, you know this carbon-carbon double bonds, because it's double bonds, it means it has to link to two other things, right? Each carbon has to link to two other things. If you look here, this carbon here, let's just say look at this carbon here, it made two bonds with this other carbon, and it made one bond with the other carbon, right? So in this case, what will be the fourth bond it has formed with? Hydrogen. Hydrogen. So in this case, cis and trans, we're talking about the position of those hydrogen in relation to this double bond. We're talking about the position of those hydrogens in relation to the double bonds. So, cis and trans. Now, trans would mean that your hydrogens are opposite to each other in this double bond. Okay? Hydrogens are opposite to each other in this, in relation to the C double bond. Okay? So in this case, this will be carbon, this will be carbon. Okay? Good so far? Cis, if trans is opposite to each other on the double bond, what does cis means?
They're next to each
Next
other?
to same side of the double bond.
Not next.
Next to or same side. So in this case, this or okay, it could be both up on the top or it could be both down the bottom. Okay? Yes?
But the trans could also be the right being down and the left being up.
Yeah, as long as they're opposite.
Okay.
Always.
Okay? HR on the same
Plane.
side explain the double. Are we okay with this?
Yeah.
Okay.
This is still under lipids, right?
Lipids, yep. Because are we okay with this so far? Now these, okay, there is a when we talk about, when we go into the lesson about lipids itself, we're going to talk about more of the ramification, why trans. So because of that, the structure of the cis fatty acid versus trans fatty acid, there's a structural ramification to this. We're going to talk more about then, but we're going to leave it there. So we covered basically what a fatty acid by itself look like. We look at the simplified form. We know the glycerol is. We know the ratio of the glycerol versus fatty acid, and we talk about both in terms of unsaturated fatty acid, presence of a double bond. We have trans fatty acid and cis fatty acid. Okay. Now, we're not gonna forget. Actually, you know what? Let's move forward to so in this case, when they're joining things, what happened? Okay. Now, I'm gonna erase this box, but think about this. So when you look at here, this is a fatty acid. This carbon has a double bond O, have a bond, have an OH here. Glycerol by itself, it also have an OH here for each of these carbons. And we said the ratio is one glycerol to 3 fatty acids. So what doesn't seem to add up when you look here? What doesn't seem to add up? Yes?
There's only carbon. No. There's hydrogen.
Something doesn't add up. Yes?
Is it only because there's one hydrogen in the middle?
Hydrogen? Not quite hydrogen. Earlier you asked a question about this particular oxygen. You earlier it's like, are these oxygen part of the fatty acid or part of the glycerol? So if you look here, there's oxygen here, there's also oxygen here. This doesn't add up.
There has to be 2, right?
So what happened is this. When organic molecules join together, now because we're talking about these very small molecules, yes?
Water.
Thank you. So in this case, when these small molecules come together and form a bigger molecule, the reaction of small molecules coming together to form a bigger molecule, water will come out. Okay?
Oh.
So in this case, I will just draw this in a smaller scale. Okay, so in this case, OH, boom, 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 like this.
Okay, and
Right.
that's how we get H2O.
Now, when these join together, you end up having draw the whole thing. You will end up having so water, notice that one of the oxygen has to go and 2 of the hydrogen has to go, so water will come out. Okay? Water will come out. in this case, this is what in biology or biochem we call it, not synthesis. I know in chemistry things are building together, we call synthesis. In biochem we call this a condensation reaction. Reaction because water is coming out. Just like if you breathe on the cold glass, there's condensation, water forming. It's a silly reason to call it that way, but hey, that's how the name stuck. Okay? So condensation reaction, smaller molecules combine to form bigger molecules. Okay?
This is only for
Water.
organic compounds, right?
So, what?
This is only for organic
Yeah.
compounds.
Are we okay with this? Now, just to double check, so I don't accidentally say this wrong thing, but when you, another way to call, and you see this on the next page here, another way to call condensation reaction is what we call AKA anabolism. Anabolism. Okay? Yes? Okay. So condensation reaction, reaction that combines smaller molecules together to form bigger molecules. Another way to call it is anabolism. Just one way to remember it is if some people would take anabolic steroids to bulk up. Okay? Anabolic steroids to get bulked up. So anabolic means forming bigger things. Okay? Are we okay with this? We slightly jump ahead to the next page. So if you can imagine 3 fatty acids joining in a glycerol, you end up having 3 water molecules coming out. Okay? Good? Yes?
Just have a question. When's the next class?
What?
Do you know when our next class will be?
What do you, when?
Next Tuesday?
What?
Why? Is the class over?
No. What?
Is our class over already?
No,
The
it's
next
just a-
test.
Oh, tests!
Test.
I haven't looked that far yet.
Okay.
It's all just like a month.
The next class.
It's like
Yeah.
Class over already? Wow.
No,
So-
40 minutes.
Awesome. Proteins. Today's survey class. Is that proteins?
It's interesting because you know.
Yeah.
I really like the whole organic chem or DP chem as well as the biochem that is almost being taught side by side at this moment because it's nice. I can actually talk about some functional groups, which both classes do need to know.
Do we have to know all carbohydrates by heart?
For this course, glucose alpha, beta, maltose is 2 glucose combined together. Lactose is a galactose and a glucose combined together. Starch is all alpha glucose. Cellulose is all beta glucose. Not as much as probably, if I miss something, I'll let you know. But that's pretty much good. Now, proteins, you can see now, first time you see it, there's a general formula. General formula. General formula is this. For each, a couple of things. Proteins are large polymers of amino acids formed together. Did you guys learn what polymer is in your previous studies? No. Okay. Polymers.
Isn't there like layers of monomers and polymers.
Good. So you have the idea of polymers versus monomers. Polymers is from chemistry. You're having a large molecule made up of repeating units of smaller large molecule made up of small repeating subunits. Large molecules made up of smaller repeating subunits or monomers. So monomers are the smaller subunits. When you have a whole bunch of these smaller monomers connect together, you have a polymer. So starch, for example, is a polymer of glucose. Okay. Now, proteins are polymers of amino acids. That's why last in 1.5, when we talk about like, oh, can you form smaller organic molecules, and then talk about deep sea vents, talk about amino acids, or the Miller-Urey experiment was able to form amino acids, and because when amino acids come together, you can form protein, which is structural as well as getting chemical reaction together. Now, the general formula for amino acids is this. C, you have an NH2, you have a hydrogen, let's put the hydrogen on top. Doesn't matter whether it's hydrogen on top or R. And then you have a C, O, OH. Okay? And you have an R here.
Rest.
Hmm?
Okay.
This is literally what we want.
That's why there's R1, R2.
Okay, so now you guys can see this amino group, NH2, that's amino group. Hence, it's called amino acids. Okay. This CO double bond O, OH, that's the carboxyl group. Carboxyl group. So in chemistry, when you're hearing this term called carboxylic acids, they're talking about acids that have these groups. Okay? Now, the R, you can see it's like R1, R2, R3, R4. There are 20-something different R groups for amino acids. 20-something. 23, 24, something along that line. And each R group are completely structurally different. You don't need to memorize any of it. You just need to know them as R. In your second and third year, you will learn it, but in university. But by then, you work with them so much, you kind of memorize it. So, each R group is different. For this course, we really only care about 20. Okay, good so far? So amino proteins are just amino acids combined together. For today, you might as well just learn. So proteins are polymers, amino acids are monomers. Proteins. And you'll see this term polypeptides. Okay, that's protein, that's another fancy name for protein. Monomer will be the amino acids.
What is R though?
R is a structural group that's variable, that's different between all 20, 24 different amino acids. Okay? Some of them is just a hydrogen, some of them will look very different. Good? All right. Nucleic acids. Now, for this lesson, you don't need to know so much about a nucleic acid. We actually would save this for the genetics unit, the structure of nucleic acid. But right now, what you need to know is that RNA is using ribose, deoxyribose use DNA, and they actually use phosphates. That's about it.
That's what's called RNA.
Yep, RNA and DNA.
DNA.
Good. Now, the other stuff, let me double check. The other stuff you can read, so what metabolism means, what does enzyme mean, so you can read this. That's not hard to understand. Now, anabolism forming of macromolecules, bigger molecules by condensation reaction. We addressed that here already. This is the example that you should know and memorize. Two glucose together will form a maltose, 2 alpha glucose.
Oh, yeah.
Okay? And water is always released. Catabolism. Not cannibalism, sorry. Catabolism. Catabolism. So the opposite of anabolism or condensation. So condensation, reaction, or anabolism. The opposite would be hydrolysis. Hydrolysis reaction. Or catabolism. Okay? So when you're having smaller molecules, when you have small molecules forming into bigger molecules, that's anabolism or condensation reaction.
The opposite is conversion.
Exactly. The opposite of it will be hydrolysis.
So is water absorbed?
So you actually use the water to bring that bond.
Okay.
Okay? So earlier, if we go back to this example here, when you have the OH from the hydroxide, from the glycerol, and the OH from the carboxylic group, one of them leaves, and then the 2 hydrogen leaves, this and forming this bond like this, COC, connect them together. You're using actually the water on the opposite direction. It would actually attack here to this carbon and then push that to separate this out. So the reason why you call it hydrolysis is lyse means split,
Hydro means water.
hydro means water. So you're using water to split things. So condensation reaction, you release this water. Hydrolysis reaction, you use water. Release. Just good? Clear? Now, let's see. Conceptually, this is the more or less, this is the section where I need to explain it to you. For the rest of the handout, it's part that you can read and understand it. It's not challenging in that aspect. So, any other questions? In this case, I'm going to leave you to it. Two things that you can do right now in the rest of this class time. Either work on this note, the 2.1 note, or continue on this activity, building the molecule with a partner, answering those questions. Again, because one of the ways you get better at with these molecules is by being more comfortable with them, and building the molecule sets will be easier.